Hello students. So this is Venkat Santosh, your personal math mentor. Okay, so we are going to take the bridge course as we have discussed earlier. So there is a lot to explore over here. Now we are going to go with the basics. I'm going to show you what we are going to discuss. And not only that, why we require JEE and its coaching and all these things. We are going to discuss that one also. Right. So if you are going to see in the latest innovation world that whatever that JEE coaching is going to take the examination, that is getting into us to IIT campus or NIT. There we are going to have innovative world. All the professors are going to check your innovation, and you can see that there we are going to do coding as well as construction and drones and all these things, and construction part is also there. Not only that, recently you might have seen that Samsung has given a presentation in Las Vegas Sphere. In that website, Las Vegas Sphere, if you're going to go, there will be a lot of mathematics. That is advanced mathematics, but the basics that we are going to learn over here. All this is about, they are going to check logical skills, not only logical skills, analytical skills. So we are going to prepare for that. For that we need some bridge course because we are struggling with mathematics from the beginning. So here we are going to take this bridge course and let's get into JEE coaching, right? On that note, we are going to start with real numbers. First, we are going to start about counting the numbers in the evolution process before the common era. So how we are going to count the numbers? That is a bigger task for us. So the people over there are trying to find some gestures to count the numbers. You can see the symbols over here. They are using the symbols to communicate to each other to count the things and objects, right? So you can see that these gestures they are using to communicate. Not only that, to count the stars in the sky and planets over here, we are going to use some gestures also. Before common era, prehistoric times over here, if I are taking, they are using stones, sticks and hand over here to show how we are going to communicate to each other. Right. So stones they are using, sticks they are using to count the number of objects, number of things, so that we communicate to each other, right? So we can build something. And they are using wood over here and stones. On that they used to write these symbols to communicate, right? And that is how we invented the system of natural numbers, right? So here you can see we wanted to count a number of apples over here, and not only that, if we wanted to count number of fingers over here, right? For all these things we need a system, right? That system is called as a natural number system, and we denoted by n over here. All these numbers 1, 2, 3, 4 are the symbols that we have defined, we have derived to count the objects over here up to infinity. When we are taking this entire set is called as natural number set, right? So if I am going to take natural numbers, again that is distributed into these numbers over here. I am going to explain each and everything over here. First one is odd numbers which are not divisible by 2. Let's say if I am taking 3, obviously 3 is not divisible by 2. We cannot make into 2 equal parts such that they are going to give natural numbers. That is 3 over here. Not only 3, if I am going to take 5, 7, all these numbers are odd numbers here, right? Now even numbers, if I am taking, even numbers are divisible by 2. Let's say 2, 4, 6, all these numbers are divisible by 2. You can divide 2 into 2 equal parts which are going to give natural number, that are 1, 1. Now we have consecutive numbers which are going to be differ by 1, you know already that part, and prime numbers which are going to be divisible by 1 and then that number itself. Let's say 7 is there. 7 is divisible by 1 and 7 itself. Okay, now that is why 7 is called as prime numbers. You know all the prime numbers, 2, 3, 4, 5 and all these things. The only even number which is prime also is 2. And then we have co-prime numbers. Co-prime numbers is nothing but that if I am going to take two numbers a comma b, their highest common factor must be equals to 1. If I am going to take, let's say 50 is there and I am going to take 7. 7 if I am taking, 50 if I am taking, their common factor is always 1 only, and that is highest common factor. That is why 50 comma 7 are what? Co-prime numbers. twin prime numbers. The prime numbers which are going to be differ by 2. Let's say if I am taking 3, if I am going to take right, 3 and 5 if I am going to take over here. 3 or 5 differ by 2 and they are prime also. That is why they are called as twin prime numbers. Can anybody give 2 more pair of twin prime numbers? Right, I am going to raise my volume. You can see that twin prime numbers are there. Twin prime numbers are going to be differ by 2 and they are prime numbers also. So 5, 7, very good. Very good. Rohan is giving 5, 7, 11, 13. Very nice. Wonderful to see that in the comments you are giving all these numbers. Right. So all these numbers are twin prime numbers. Okay, so that is how we have divided natural numbers into subparts over here. Now let us take a question on this. So there are 2 numbers. Let's take x plus x comma y. 2 numbers are there and sum of them is equals to 25 they have given. Let us take x comma 2, y are 2 numbers over here and is equals to, they have given sum is equals to 25 they have given. If one number is 7 more than the other, let's say y is 7 more than other. So I can write y is equals to 7 plus x. Now plug in this y value and the first equation, what we are going to get, x plus 7 plus x is equals to 25 and x plus x you can write it as 2x, 27 minus 7 is going to be, and that is going to be 18. 7 I am taking that side, 27 minus 7 is giving us 8. Now you can see that x is equals to 18 by 2 which is 9. The 2 numbers are going to be 9 and 7 raised to that 9 is going to be y is equals to what? X plus 9 which is x plus 7, that is going to be 18. So sum of these 2 numbers if I am taking, and if I am going to raise that by 7 over here, you are going to get what? 16 over here. Now you can see that 16 plus 9 is equals to 25 and y is more than 9 over here. That is how you are going to solve simple problems. This is all about, like, I am giving first basics of this, and if you are going forward in this real numbers and all these things, I am going to give the glimpse of complex numbers also and the uses of complex numbers in the real world also. Okay, now so just making sure that we are going to revise these basics, right? Next I am going to take integers. Then natural numbers we are using to count the objects. Now why do we need integers? For example, I am going to take a chocolate in a given random day that is going to be 300 calories, but I wanted to become slim. So I'll go to gym, I am going to burn some calories by running and something like that. So I am going to burn 300 calories. 300 calories if I am burning. So what is my deficit, calorie deficit in a day, in that day? What will be that? 200 calories I have taken by chocolate, and how much I need to deduct from that? Minus 300. To show this one over here, I am going to count these calories over here with one symbol over here. What is that? Negative symbol I am going to write before that 300 over here. That is giving us what? 200 minus 300. Now you can see we are going to left with minus 100 calories over here. Nothing but 100 calorie deficit I did on that random day. So to show that one, we are going to take some more numbers over here by giving symbol, negative symbol to natural numbers. Now you can see that the same way there are ripe mangoes over here which are going to damaged in 2 days. And there are wrong mangoes over here which are going to be come for longer days. Now if I am going to take, I am craved for mangoes because this is summer season as you know already, right? So if I am going to take ripe one, there is a discount of 2 rupees. So to show that discount over here, we are going to use negative symbol for that $10, which is going to come for only $8 for me. So to show all these numbers over here with that symbol over here, we are going to take some numbers like this by taking natural numbers, by giving this symbol over here negative. We are going to extend the number line over here like this, minus 3, minus 2, minus 1, right? So that is giving us what? Negative integers or total integers you can take here. Integer system over here, you can see that is entire set is called as what? Integers. And this set is denoted by I or Z. I or Z. Now again I wanted to divide them into subparts there. Okay, now first one, if I'm going to take, what is that? Positive integers. You can see that is denoted by z plus. Only positive integers will be there. That already we know that positive integers are also called as natural numbers. Not only that, we are going to take one more set over here, negative integers, and denoted by z minus there. And all this set we are going to take, that natural numbers we are going to take with multiplied by negative sign over here. They are going to give us negative integers. And if you are going to include 0 for these positive integers, they are becoming what? Whole numbers, right? Now on these integers, I am going to take one more question over here. Let's say I am going to be in third floor and I wanted to go to basement 2. Now how many floors I am going to descend? That we are going to find out. Let's say I am in third floor here. After that we are going to have second floor, first floor, and ground floor. Ground floor we are going to include over here -1, -2. My scooty is parked at -2 level or basement 2. So how many I am going to descend over here? How many floors we are going to descend here? That you can see 1, 2, 3, 4, 5, total of -5 floors. Okay, now to show that over here we how much descended, we cannot say like 5 is descended and all these things. If I am going to put over here symbol minus, directly you are going to get to know which floor you are going to be there, right? So that is how we are using integers over here. And in the elevator you can see already that numbers with -1, -2 symbols also, right? And then we are having, you can see I wanted to find my height now. Okay, my height, if I am going to measure with a tape, it is going more than 6, right? So more than 6, I wanted to make it near to what is that exactly measuring. Okay, now so I wanted to know that. That is why I am going to divide. It is lesser than 7 obviously. So if I am going to take 6 to 7, I wanted to divide into 10 parts. Okay, now that is 6.1, 6.2, 6.3, like that we are going to divide. Or else you are going to take 61 over here. 61 is divided by 10 if I am taking, that is going to give us 6.1 over there. Right, so my height is going to be 6.1 over here. To know that, I am going to divide that one interval over there into 10 parts. So that is giving us these numbers over here, which are called as rational numbers. Not only height, but also you can see over here weight. Sometimes it is going to be 80, 87.5, 87.6. Like that we are going to take 0.6, 0.7. Okay, now so to represent those numbers, we are going to use what? A rational number which are of the form P by Q. All these numbers P by Q, where P comma Q belongs to Z, as I told you, 1 by 10, 2 by 10. That entire interval is divided by 10 parts, and we are going to take 1, 1, 1 like this. 1 by 10, 2 by 10, 3 by 10, up to if I am taking 9 by 10. And these numbers 1, 9, 1, 2, all are integers, right? So if I am taking P by Q form, P comma QR belongs to integers over here. Q is not equal to 0, because if Q is equals to 0, that is not going to be defined, definitely, right? We have not defined that one so far. And these are all called as rational numbers, and it is denoted by Q over there, right? Now, if I am taking all these numbers over here, P by Q, let's say Q is equals to 1. If I am going to take Q is equals to 1, it is going to become P only. P already belongs to what? Integer only. So P by Q form, if I am taking Q is equals to 1, all these are numbers are going to give us integers. So you can say integers is subset of what? Rational numbers, right? So all recurring decimals are going to be rational numbers. Let us see that how we are going to get that. Let's say 1.11111 is there. This is recurring. Recurrent decimals are there. So it is going like this. It is never stopping over there. Let us assume this point over here to be S over there. Now I wanted to find exactly S in terms of what? P by Q. I am going to multiply this one over here with 10 over there. Now let me know what we are going to get over here, right? Yes, 11.111, it is going like this. You can see that. Now I am going to take 10S minus S, means this is equation 2, equation 1. I am taking 2 minus 1. 2 minus 1 if I am taking. What you are going to get? 10S minus S. That is obviously 9S is equals to, on the right side it is going to be, after decimal points all 1 are there. 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0. All after decimal points are becoming zeros. 11 minus 1 is going to give us 10. So S is equals to, can I write 10 by 9 over here? Yes. So 10 by 9 is your number if you are taking 1.11111 like this. So all the recurring decimals are also called as rational numbers. Okay. Now let us take a question on this. Now I have 500 rupees. I am giving, or Rahul has 500 rupees. He is giving to his friends 2 by 5 of this 500 rupees. So I am taking 2 by 5 over here, 2 by 5, and he has 500 rupees. So let us take that how much his friend is getting over here. So that is equals to, we know that 5 over here cancelled with 500, how many times? 100 times. So we have left with 2 and 2, 100, which is equals to 200. So how much Rahul's friend is getting? 200. And how much Rahul is going to left with? Total is 500 over here. And I am going to take this 200 away from his pocket. Then he is going to left with only 300, right? So this is how you are going to use the rational numbers to find the the amount over here which is given to his friend by Rahul, right? Then some numbers which are not going to be written in the form of what? P by Q. So those numbers are called as irrational numbers. So we cannot express them in the P by Q form. Let us take an example like this. X square minus 2 is equals to 0 equation is there. I wanted to find x over here. Then x square is equals to 2 over there. X is equals to, you are going to write some number which is going to give us always 2. That is going to be written as what? Square root of 2. So square root of 2 we cannot write in the form of what? P by Q. That is why they are called as what? Irrational number. In this case it is root 2. And sometimes you are going to get some transcendental numbers. They are called pi and Euler's constant, all those things, right? Pi we have studied about that. It is the ratio between the circumference and the diameter, right? So all these numbers are called as what? Denoted by Q complement. This is complement, or you can write Q power C. Okay, na? So this is a complement set of rational numbers which is representing irrational numbers, right? And then some of the numbers over here also are called transcendental numbers. As I told you, they are pi and E over here. Pi is the ratio, as I told you, and E is also there. So if I am going to take here as a right angle triangle with 1 over here, base and height, then what will be your diagonal? It is going to be root 2 from Pythagorean theorem. So that is how we are going to see the numbers over here, irrational numbers in the real world. Whenever there is a right angle triangle, you are going to get root 2 as irrational number over here or the hypotenuse, right? Right, so pi and E also we are having, and root 2 as I have given already is the root of what? X square minus 2 is equals to 0. Now if I am going to take a square shaped park is there here. I am going to take here square shaped park is there, and what is that? A total distance around the park is 20 centimeters. Total distance, if I am taking 20 centimeters, tell me what is one side is going to be. I think you can answer that. One side is going to be how much? Yes, it is going to be 5. Very good. Right. So if I am taking this one over here, 5, 5 over here, 5 over here, 5 over here, sum of all these four sides is going to be 20 over here. Now 20 if I am going to take, I wanted to find diagonal. Again we are going to use Pythagorean theorem, that 5 over here. We know that if I am taking, this is C over here, this is A over here, and B if I am going to take, A square plus B square is equals to C square, that we know. That is going to give us 5 square plus 5 square is equals to C square, and 5 square plus 5 square, 25 plus 25 is giving us what? 50 there. C is equals to square root of 50. So that is the irrational number over here we are getting as a diagonal of the park. If a person wanted to go to the one vertices to opposite vertex, then he is going to walk for root 50 meters, so root 50 centimeters over the park. Right. Now we are going to introduce the concept of real numbers, where we have taken the rational numbers as well as irrational numbers. The union of these two is going to be real numbers, because all these numbers existed in a real world, right? So you can see that real number line we have taken over here by taking origin is over here as the center, and we are taking all the natural numbers on the right side and negative integers on the left side over here, and some points over here there. 0.8 is a rational number there, root 2 is irrational number, 2.2, e, pi, all these numbers are there. You can see all these numbers can be literally written on the line, right? We can show this one over here. That is why they are all real numbers. Now real numbers, again you can see entire structure over here, all the numbers that we have discussed over here. Real numbers as divided into rational number as well as irrational number, which are divided by q and q complement there. Again rational numbers are divided into integers and non-integers. Non-integers we are going to have again fractions and decimals over there. 1.1 just now we have taken, and my height 6.1, all these things we have taken over here. And integers, if I am going to take negative integers, 0 and positive integers. 0 and positive integers together you are going to call them as whole numbers. These positive integers again called as what? Natural numbers. Natural numbers also. Okay, now. So that is how we have divided all the real numbers into the sub parts over here, subsets. Now here there is a rod over here of root 5 length over here, and there is another rod over here 2.5. 2.5 also can be written as what? 5 by 2. So very simple. Why I am giving this one? To show the numbers over here, because there, if I am taking that rods over the existent real world, that is why we are going to add them, which is going to give us some number over there, which is going to give us the sum of their lengths over there. So which existed in real numbers, that is what I am showing over here. These numbers are also real numbers, right? So these numbers here we are going to discuss in the next class. Those are called as Surds. So there will be a lot of concepts in Surds. I am going to explore all these things tomorrow with you, right? And then there are algebraic identities. These are very important, I am telling you. There will be a lot of applications using this in JEE. JEE you are going to have a lot of applications. Some of these identities will come frequently in JEE syllabus. Okay, now we are going to use this. So be careful of using all these identities, and they are important. You practice on this. Okay, now, right? So the first one you know already. This is simple. That a plus b into a plus b we are multiplying. So that can be written as a plus b whole square. A plus b into a plus b. You are going to multiply a square, b into b square, and a into b is going to give us ab plus b into a if I am taking ba, which is going to give us a square plus b square plus 2ab. Nice. So which is this formula over here. Similarly, you are going to take the next formula over here, a minus b whole square. That is also easy, right? And then a plus b into a minus b is giving us a square minus b square. For example, I wanted to multiply two numbers over here. 3 plus 4 I am going to take here, and 4 minus 3 is there. So instead of simplifying and over here directly, you are going to write over here 4 square minus 3 square. This is a simple thing, but you are going to get other things over there in again integration and all these things. So that will be difficult over there. For now, I am going to give this one here, right? And adding these two, you can see here 2ab will get cancelled. You are going to left with 2 into a square plus b square. Or if you are taking the difference of these two, so you can see a plus b whole square, a minus b whole square. These two difference, if I am taking 4ab, you are getting, right? So for example, I am going to give a question over here. Let's see. I am giving the value of ab is equals to something like 5 I am giving. ab is equals to I am giving 4 over there. Okay, now how do you find? See, if you want me to give a bigger numbers, I will give that. Okay, so I am going to take different one here. Right, so I am going to take here some 10 there, and 21 I am taking. Now, how do you find this, the numbers a comma b here? For that one, I am going to use, as I have given over here, a plus b whole square minus a minus b whole square is equals to 4ab. Why don't I use a plus b here and 4ab there to find a minus b? What would be a minus b whole square is equals to, from this can be written as a plus b whole square minus 4 into ab. Why I am taking in this way only? Because I have a plus b as well as AB there. So I am going to plug in all these values that I have taken. A minus B whole square is equals to, what is A plus B here? 10. 10 square is going to give us 100 minus 4 into 21 is going to give us 84. I think we have left with 16 over here. So A minus B whole square is 16. Now what would be A minus B is equals to? Isn't it 4 plus or minus 4 over there, right? So that is plus or minus 4. Now you can simply add this A plus B, A minus B. If I am adding these two over here, then what we get here? Sum of these two is giving us 2A here on the left side. If I am going to take plus over there, 10 plus 4 is giving us 14. Or if I am taking minus over there, 10 minus 4 is giving us 6. So A is equals to either 7, 2A is equals to 6 if I am taking, A is equals to 3. So 7 if I am going to plug in any of these equations, let's say first equation. So A is equals to 7 if I am going to substitute over here, B is going to give us what? 3 there. So the two numbers we can find by using this property over here, right? And then we have one more equation here. This we are going to use here in quadratic equations and all these things. You can multiply these two numbers x plus a into x plus b, which is going to give us x square plus a plus bx plus ab. Let's say I am having here x plus 3 is there and x plus 15 is there. Now how do you multiply this one over here? Directly you are writing x square, 15 plus 3 is going to give us 18x, and 15 into 3 is going to give us what? 45. So simply you can write by taking this identity over here, right? And then the same way, if you are taking one of them is negative, you are going to get a minus b and minus ab there, right? Again, if you have three terms over there, x plus y plus z, same like first one over here, we are having only two terms there. Here we are having three terms here, and squaring, then you are going to get this simplification over here, just like I have shown you for this first one over there. And then if you are taking one of them, z by replacing by minus z there, square will be not changing over here, this symbol, but whenever this z over here, when we multiply it by other numbers here, you are going to take minus there. So that is why the last two terms are getting minus over there. And I wanted to simplify this one by using the formula that I have taken. I have given that a plus b whole square minus a minus b whole square is equals to 4ab. So here the same way, 4 into, in the place of a we are having 2x, and in the place of b we are having what? 3 over there. So which is going to give us 4 into 2 into 3 is giving us what? 24x. You can directly write that. No need to simplify this, no need to simplify that. If you are having the formula, directly you can write down this one over here, right? And then some more algebraic identities I am going to show you. A plus b whole cube we are having, a cube plus b cube plus 3a square b plus 3ab square, which can be simplified again into 3ab into a plus b. Same way, I have given a plus b whole square. You just have to multiply a plus b and simplify further, and adding all these you are going to get this one over here. A minus b whole cube also same way, and this one over here you can see these are also important here. X cube plus y cube, you can write it as x plus y into x square minus xy plus y square. For example, I have a bigger number to solve over here. Let's say a cube minus 8 is there divided by a minus 2. How you are going to write in terms of square of a? There you can see 8 can be written as what? And if I am taking plus over here, okay. So 8 can be written as here 2 cube there. So I am writing this one over here, a cube plus 2 cube divided by a plus 2 is there, and a cube plus 2 cube can be written as a plus 2 into a square minus ab plus b square. Here in the place of b, what we are having? 2 there. So I can write this one directly, a square plus 2a plus, again what is in the place of y over here? 2 only, no? So 2 square is going to be 4. That is how you are going to use these identities to simplify easily, okay na? So by using these identities, we are going to simply write down the direct value over here without any simplification in the question itself, right? And this is very important, x cube plus y cube plus z cube minus 3xyz, x plus y plus z into this one over here, this entire expression x square plus y square plus minus xy minus yz minus zx. Please let me know in the comments that how many of you know this already. I am going to give a question on this afterwards by proving this if you know already. Okay. Very good, very nice. Swati, yes, very good. A lot of people know, right? So I'm going to give you the question also. You might be not knowing. This is very important. This is going to come in matrices determinants. Not only in that, you're going to get in trigonometry also in various questions. There will be concept of trigonometric equations. There will be a concept called determinants. In that also they are going to include on all these things. So this is very important. You must know this identity over here. I have seen in lot of questions this identity they are using. Okay, na? So just that we are going to multiply these two over here. I'm going to show you. See, x, if I'm multiplying all of them, you are going to get x cube, xy square, and xz square minus x square y minus xyz minus x square z. And then if I'm multiplying y over here, then what do you get? Y into x square, y cube over there, and then you are having y into z square there minus xy square minus y square z minus xyz. And the last term, z, we just have to multiply z also. That is also easy, zx square, and then z into y square here if I am writing, obviously z cube there minus z, and then z into this one over here, zxy, and minus yz square and minus xz square. Okay, na? So you can see that x square z is getting cancelled over here and here. Similarly, here if I am taking xz square, here also xz square is there, and x square y, and this one xy square is getting cancelled with here xy square, and zy square is getting cancelled with z square y here, and all the terms zy square, all these terms are getting cancelled. These two are getting cancelled here. All these terms are getting cancelled. We have left with x cube and y cube, x cube here and y cube and z cube, and here xzy, xzy, xzy. Adding all these things, you are going to get minus 3xyz. Right, so this is the identity over here. I'm going to give the question on this later, and let me show you some more properties here. And this one you can write it over here as this one over here, perfect square. I am going to write just now one more question on this one over here. Right, so here you are going to write x square plus y square plus z square is there. Why don't I multiply over here 2 for every term over there? So I am going to take here 2, multiply it for 2 over here and divide it by 2. Okay, what I am trying to do here is that I am just dividing with 2. Not only that, I am going to multiply with 2. 2x square, 2y square, 2z square. Okay, na? So now here also you are going to get 2xy minus 2yz minus 2zx. Okay, na? I just multiplied by 2 for every term. So obviously when you are multiplying on the left side of this expression I am taking here, you have to divide also. Now 1 by 2 here, 2x square I can write it as x square plus x square. I am taking minus 2xy here, and this one also there here, y square, 1y square I am taking here, one more x square I am taking over here, because there are two x squares here, I am taking x square here and x square here also, minus 2, here we are having zx here, zx, and 1 z square I am taking over here. What we have left with? One x square, one x square is gone, 2x square, and y square is one time we have taken, z square one time we have taken. So we left with y square minus 2yz plus z square. Is it correct? Now I can see that here the very second formula that we were taking in identities. What is that? A square minus 2ab plus b square. What we can write it as? Half into x minus y whole square, isn't it? The same way we are getting what? Y minus z whole square, z minus x whole square. Now let's see the application of this. You understand, I think, all this part over here, how we are taking this. This is also very important. So what if I am giving x square plus y square plus z square minus xy minus yz minus zx is equals to 0. Okay, now? And I am giving this one also, x plus y plus z is equals to 12. Now, what would be the values of x, y, z? What if they are going to ask like this? Can anybody answer this? Would you try that? Very good. Right, so you might be trying this. Let us check this one over here. If I am going to take this entire is equals to 0, if I am going to substitute in this, then you can take this left side expression as half into x minus y whole square plus y minus z whole square plus z minus x whole square is equals to 0. Now you can simply multiply 2 over here, which is going to give us 0 only. 2 into 0 is going to be 0. Okay, very good. 0 you are getting answer, 5 you are getting. Nice. X is 5. Nice, nice. Let us see what we are going to get now. Now you can see that if I am going to take is equal to 0, there is no other possibility, because this is positive value, this one over here is also positive value, this one over here is also positive value. All these are positive values, must be equals to 0. What is the other possibility except that all these must be equals to what? 0. This must be 0, because except 0, if I am taking any positive value, you are going to get more than 0 only. That is why I am taking x minus y is 0. Not only that, y minus z is also 0, and also z minus x is also 0 over here. Now x is equals to y, you can see, and from this y is equals to z also. From there z is equals to x. X is equals to y is equals to z. Putting all this over here in this equation, x plus x is equals to 12 over there, which is giving us 3x is equals to 12 over there, and x is given as 12 divided by 3 is going to be 4. You can see x is equals to 4, which is going to be not only x but also y but also z. All are equals to 4 only. You just substitute in this all these values over here, x, y, z, you are going to get definitely 0, right? So this is how you are going to solve the problems, by using this identity there, right? Next identity that we are having, x square plus y square, already we have taken over here, half into sum of the square and subtract if I am taking different square over here, right? And then this is also very important, this one over here I have seen many times in JEE, that they are giving in integration also, differentiation also, they are asking for differentiation. You might be learning in physics already differentiation, there they are going to ask the differentiation in the denominator. So whenever you are going to get this expression over here, try to think about this identity over here, how to write this one. Randomly, if they are going to ask you to find the differentiation of x power 4 plus x square plus 1 divided by x square minus x plus 1. Directly you can write what? X square plus x plus 1. This directly you can take the differentiation over here, because that is the identity. Let me prove this by taking these two over here. You can see that this I can write it as x square plus 1 x over here. I am just separating these two terms, and here also same way, x square plus 1 minus x there, and this one I am taking as a, this one over here b, this one over here a, this one over here is b. A plus b into a minus b formula, which is going to be x square plus 1 whole square minus x square, that is b square, which is going to be x power 4 plus 2x square plus 1 minus x square. So 2x square is there here, x square is there, 2x square minus x square is going to give us what? Plus x square over there plus 1, right? So you can see that multiplication of these two is giving us x power 4 plus x square plus 1, right? And then this one also here, if I am taking a square plus 1 by a square is equals to sum of these two squares minus, actually if I am taking this is b square over here and this one over here b, and minus 2ab must be there, but b turned out to be reciprocal of a, right? So if I am going to take a into b, b is reciprocal of a is getting cancelled, you are going to left with 1 only. That is why that is eliminated, you are going to get the value of over here as minus 2 itself, right? So a square plus 1 by a square is equals to a plus 1 by a whole square minus 2. Just in case if I am taking instead of minus, I wanted to take Plus in the place of plus over here, I am taking minus over here. Then you are going to get over here plus. That we are going to see the next formula here. You can see that here if I am taking minus, you are getting plus over there, right? And on that I am going to solve a problem over here. A plus 1 by a is given is equals to 3 here. I wanted to find, just now I have written the formula, that is a plus 1 by a whole square minus 2. I know the value of a plus 1 by a, which is equals to 3. 3 square minus 2 is going to give us 3 square minus 2 is equals to going to be 7. 9 minus 2 is going to give us 7. If you know this identity, directly you can write down. That is as simple as possible, right? Now if I wanted to find this one. The same way I have taken the identity, I can take the identity for this one also. That is a plus 1 by a whole cube minus 3 into a plus 1 by a. Because we have seen already that a cube plus b cube is equals to that a plus b whole cube minus 3ab into a plus b. But ab value turned out to be 1 because these are reciprocals here, right? So that is why it is becoming 1 over here. Now we have already these values, a plus 1 by a is equals to 3 only. So which is giving us 3 square minus 3 into 3. So that is very simple to find. 27 minus 9 is going to give us what? 18. Now if there is a larger power over here, in the case of this one over here, a power 4 plus 1 by a power 4, you can write this one over here as a square plus 1 by a square. In the place of a, now we are having what? A square whole square minus again 2 only, right? So this is equals to this. Here we are having a square plus 1 by a square. Here we are having a power 4 plus 1 by a power 4. In the place of a square, we are having a power 4. Nothing but a can be replaced by a square. Same way here I am replacing a by a square, which is going to give us over here already a square plus 1 by a square value we have got 7. 7 square minus 2. What is 7 square is equals to 49. 49 minus 2 is giving us 47. So if you know all these identities, you can see how simple it is to find all these values by just taking the identities over there. Okay, na? Next, I have given that identity in cubes over there. A cube plus b cube plus c cube minus 3abc is equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Same formula I am going to use over here for this question. Now you can see a square plus b square plus c square is equals to 38 I have. I wanted to find a plus b plus c whole square value. That is equals to a square plus b square plus c square minus 2 times of ab plus bc plus ca. This is the identity that we have taken already, right? So you are going to take a plus b plus c whole square is equals to, we know already this value over here 38 minus 2 times this value over here, sorry, this is plus over here, plus we were taking, right? So this one over here plus here, 2 into what we are having here, minus 19, which is going to give us 0 over there. That means a plus b plus c is equals to obviously 0. What was the identity I am talking about? This one over here. This is equals to a plus b plus c times of a square plus b square plus c square minus ab minus bc minus ca, right? So a plus b plus c already we have got 0. 0 just plug in, you are going to get entire value as 0. If you know this identity, so we don't know if you are going to take directly this one there, you cannot find the value. You can find, but it is going to take a lot of time. But what if you know already this identity? Directly you can give the value 0 over there and just take the inputs whatever they have given and simplify, you are going to get the value, right? So this is so useful, that identity solving and all these things. Now sometimes the equations will be there like this, x square plus 1 is equals to 0, right? Now what will be the equation, what will be the solution of this equation? Let us check that. So x square, if I am taking, is equals to minus 1, x is equals to plus or minus, you can write root over minus 1. Do we have any value for root over minus 1? So in the real system, real number system, we don't have any value for this one, but you can simplify for this one. So you can write over here root minus 1 is equals to, one mathematician has given that name as iota, which can be denoted by simply I. Okay, now So there are a lot of uses. I am going to show you what are the real world uses of this iota and the complex numbers. I am going to show you in the next slide over here. But this is very useful concept over here in mathematics. You are going to get it in second year, like whatever the theory that we are going to explore will be in second year only. I am going to just give the glimpse of this, okay na? So that is how we have introduced the number over here, iota. Now all the numbers of the form a plus ib, where if I am taking b is not equals to 0, then this number is called as what? Imaginary numbers. They are imaginary numbers. They don't exist in the real world, but they are useful. Okay na? What is that use? I am going to show you next. Okay na? So these numbers I am taking over here. This is called iota over here. All these numbers a comma b belongs to real numbers. B not equal to 0, then they are imaginary. If b is equals to 0, then this is going to be real number, right? So together we are going to take it as I is equals to minus 1. So example is there, 2 plus 3i is there, that is imaginary number 3i. And so I am going to show you here, if I am going to write 2 plus 3i is complex number here. So real numbers and imaginary numbers, if I am taking union of these two, total system is called as complex number system. Okay na? So all the real numbers are complex numbers, all the imaginary numbers are complex numbers. Okay na? But all the complex numbers are not imaginary here. See, imaginary, real or different numbers over here, together union of these two is going to be giving us what? Complex numbers, right? So that is how we are denoting this complex number system total as capital C over here. I am going to show you that also, right? So mathematics has given birth to imaginary numbers also, right? Uses of complex numbers, as I told you, electrical AC circuits are there. We are going to see these kind of circuits in our home, right? And then we have this signal processing communications like Wi-Fi we are using to give this YouTube live and all these things that you are using, I am using, and radio signals as well as mobile networks and audio processing signals and all these things. Using complex numbers, they are writing the equations and they are going to get that waveforms like Fourier series and all these things. Okay, now so they are using. Not only that, quantum mechanics, recently Google has introduced that quantum chip. Not only Google, Microsoft also has given marijuana, that is also there, quantum chips they are using. So quantum mechanics also, there are a lot of uses of this. And vibrations and mechanics, that you can see elevator you are using, already we have solved a problem on elevator. There also they are using vibrations mechanics, how much that elevator weight is going to be sustained by using the springs and all these things. So those vibrations they are calculating by using the equations which involved again complex numbers, right? So you can see that real plane, complex plane is also there, how they are going to go, how they are going to use over here, and this how this orbit is moving over here, the points where how we are going to use in complex plane by taking the angles I power 0, I power 1 and all these things. Iota we know already, iota is equals to root minus 1. What if I am taking I square is equals to obviously minus 1. What will be I cube is equals to minus 1 into iota, which is giving us minus iota. I power 4 if I am taking minus iota, iota square into iota square, which is equals to minus 1 into minus 1, which is equals to 1 again. So that is exactly what we are taking over here. Iota cube is equals to minus I. This is 1. Again into iota is giving us iota. Iota into iota is giving us what? Minus 1 again. So these are the number powers of iota also we are taking, right? So subset form we can see natural numbers, integers, and then we are having integers is part of, I have already explained that is rational numbers. Rational numbers is also part of again real numbers over here, and real numbers is again subset of what? Complex numbers. I am going to write in circles, that is the last part of this. I am going to take a here complex number system over here, and let's say this is one over here is complex number system, and there is imaginary set over here, and this is real set over here. Total together is complex set over here, and in this real set over here again you are going to have what? Rational numbers, and this one over here is non-rational numbers. This is q, this is q dash over here. Again in q you are going to have integers I or z over here, I or z, and again you are going to have whole numbers. Again you are going to have what? natural numbers. So this way also, by using, this is called Venn diagram. By using Venn diagram also, you can represent entire number system, including complex numbers and involving what? Imaginary number. So on that note, we are going to wind up this session. Thank you very much for joining. It's wonderful to see all of you, all the love that you are giving and checking all the solutions. Very nice. So you are going to work on this. I hope you are going to work on this. This bridge course definitely will be helpful for you, because a lot of students I have seen in my 10 years of experience, I have seen a lot of students are struggling in mathematics particularly after coming into coaching, JEE coaching directly. If you are going to take bridge course, that is going to be very, very helpful. Not only that, we have Infinity Meta app also. If you are going to subscribe to that, and you are going to get a lot of assignments in that. If you just type one topic there, you are going to get videos, assignments and questions. You can solve them. Immediately you are going to get the result there itself. You can check yourself. If any mistake is there, you are going to correct that. Okay, na? So that way you can improve yourself. Thank you very much. I'm going to share the notes also. I'm going to ask my team to share the notes. Thank you very much. It's wonderful to have you guys. Right. On that note, let's end the session. Right. Right. Thank you very much. Bye bye everyone. It's your personal mentor Venkat Santosh from Chaitanya.